This is Math 7, Section 4, Solving Algebraic Inequalities. So, in order to solve an inequality, it's very similar to an equality in the way that you solve it, except we know that just one is more than another. So when it's represented on a balance, instead of being like equals, where it's straight, one that is like this means that this side is greater than that side, will be weighed down. Whereas this one will be weighed that way. So the greater side is basically heavier. And when we say greater than or equals to, it could be either here or it could be like that. Same with less than or equals to. Either be here or it could. So there's a few ways to represent this. Now, you just say that you can do guess and check. So if you're given an inequality like x plus 3 is 4, you could try to figure out, okay, what is the cutoff here? So if x equals 0, then we would say that 3 is greater than 4, which is not true. If x is 1, we'd say that 4 is greater, which is not true. They're equal. Say x is equal to 1.1, and that would tell us 4.1 is greater than 4, which is true. So say that x is greater, but it's not equal to 1 as our answer. Okay, we could also use the balance to say if it's like this, we use this balance. Over here we have an x plus 3. Over here we have 4. Well, if we want to figure out what x is greater than, we take these 3's out. And if we also take these 3's out, then we know that the result will be x and a 1. And that's our answer, because if we take 3, we know it'll be greater than that side. So let's learn how to graph this on a number line. So x is greater than 1. I'll draw out a number line. Here's 0, here's 1, here's 2, negative 1. Now if it's like this, we draw the open circle, and then we have an arrow pointing this way. Alright, so equals is just a dot. Greater than means that it is that, like that. Less than is like this. Greater than or equal to, think of it as a combination of these two. Equal to, think of it as a combination of these two. And that's how you write it. Sorry. You can see all of that. Okay. Let's try example 8. So combine these terms. Alright, these two added together makes 1y. 7 is less than 9. Next thing we want to do is move numbers to one side. So to move that to that side, we subtract 7. 7. This gives us y, that's 0, is less than 2. And that would be our answer. Okay? B, and then it says in graph line. So number line 0, 1, 2. We'll draw our circle. Oh, sorry. Draw our circle at 2 and come back. Alright. Let's try another one. 1/2 y minus 4 plus 1/2 y is greater than or equal to 8. So what do we do? Combine. We combine those terms, we get 1y minus 4 greater than or equal to 8. Numbers to one side. Let's add 4 to both sides to get that over there. This becomes y greater than or equal to 12. Graph that on a number line. 10, 11, 12. Remember, it's a solid, and it comes that way. Try this on GP 1 and 2. Moving on, example 9. Example 9 is to solve these and graph them on a number. A little bit more complicated, but not too hard. 1.3x minus 7.2 less than or equal to 11.8 plus 3, 0.3x. Okay? First of all, we want to get x on one side. Let's move the smaller one over by, and that gives us 1x minus 7.2 less than or equal to 11.8, and then we add up here to move the numbers to one side. That by adding 7.2. So we get x less than or equal to 19. And we can graph that. 17, 18, 19. Remember, it's a solid circle, and we go because it is less than. Let's try another one. 11 minus x less than 7 plus 1/2. So first, let's get add 1/2 x here, add x here, and that gives 11, 0, less than 7, plus 1x. Then let's get the numbers to one side. So we'll do that by subtracting 7 here. That becomes x is greater than 4. Draw that on a number line. 3, 4, open circle, greater than. Try this on guided practice. 3, 4, and 5. Okay, now we are going, that was addition and subtraction, so now we want to try some things where we need to use multiplication and division. So something you really want to know is that when you divide by a positive number, then the inequality sign or that one, any of these stay in the same direction, so they don't change. But if you do the same to a negative number, then this or this will switch with that or that. So they will swap directions. Okay, it's the same as if you multiply. It does the exact same thing. So we could say multiply or divide. Remember, addition and subtraction, it depends on if you have a positive or negative number, if you're adding or subtracting, and the sign stays the same. But for these, if you do something with swaps, positive stays the same. So let's try it. Negative 5y less than or equal to negative 10. So here we want to divide by negative 5 so that those cancel. So here we've divided both sides by a negative. So our answer is with a negative, therefore these are going to swap. So instead of having a sign that's this way, we have a sign that is that way. So we could say that y is greater than or equal to 2. and then graph that on line 1 that way. There's your answer. Example 10. In example 10a, -1/2 is greater than or equal to 3. So we're going to have to multiply by a negative number to get rid of this. So remember, if we multiply by 2 on both sides, you still have to be times -2. -2 times -1/2, the 2's cancel, so it becomes p. Oops, I'm going to do it this way. So it becomes p. Remember, it's a negative, so this needs to flip-flop. It will be less than or equal to now. And then the 6. So when you draw it, and you draw a -7, -6, this will be here. It's equal to -6. B, -0.4x greater than 1.6. Well, we need to divide by a negative number. Therefore, the sign will flop. Instead of being this way, it will be that way. We get x is less than -4. So on our number line, -5, -4, it like that. Alright, this in guided practice 6, 7, and 8. Okay, last thing today is multi-step algebraic inequalities, so things where we have to do a couple of different things like multiplication and division and stuff like that, similar to algebra problems. Here, let's start with this one. So first thing to do is get one side and the other side. So x is on one side. Here we have a as our x. It could be any variable. And then numbers are not on the other side, so we're going to add the 7 to get to the other side. We don't have to switch signs at all when it's 3a is greater than 9 or 11, sorry. Now we added 7, so it would actually be 33. Okay, so now we have this. The next step is to divide or multiply to get x alone. So here, in this case, we need to divide. Now, dividing by a positive number, the sign will stay the same. Remember, up here we changed when it was negative. Here it is positive, so it stays the same. We get those cancel. Is greater than. Alright, pretty simple. Now, on a number line 11, 12, open circle. That's a multi-step problem. 11. Just as you can see. Okay. There we go. A. 4/5 x plus 1 is greater than 1 3/5. So let's do our first step from up there. To get x's on one side, numbers on the other side. X is on one side, we just need to get this to the other. So we subtract 1. Remember, addition and subtraction, we don't need to switch this sign at all. So it stays the same. We get 4/5 x is greater than 3/5. So now let's multiply to get rid of this. So instead of 4/5, we multiply by 5/4. Cancel, the 4's cancel. So multiply by 5/4. The 5's will cancel. And because this was with a positive multiplication, the sign stays the same. Those cancel, we get x These cancel, we get 3/4. X is greater than 3/4. Let's try B. And I'm just going to know how to graph these by now. 9 minus 0.2 greater than 0.2a. Okay, step 1 from up here. Get those on the same side. So we're going to subtract 9, sign stays the same. We get 9.2a, and we 12, if I'm not mistaken. Yep. Okay, so then we're going to have to divide by a negative number, negative 0.2, to get rid of this negative. So because it's a negative number, this flip-flops. So now it's like that. These cancel, so we get a, and then 12 divided by 0.2 is negative 60. Let's try C. As negative 2a plus 3 is less than negative 7 minus a. Oh, by the way, here was step 2. So step 1, get everything on the same side. So I'm going to add this a here to both sides. Since I've moved this over here, we're going to move the 3 over there. So I'm going to subtract by 3 on both sides. Let's see what we get. Negative 2 plus a is just negative a. These cancel. Sign carries down. These are negative 10. Those cancel. So negative a is less than negative 10. But we need to divide by negative 1 to get rid of the negatives. So when we divide by a negative, our sign is going to switch, and we get a is greater than 10. Final one, D. We haven't seen a distributive one yet, but we just apply the same principles as an algebra problem, where first we distribute. So that's 0. Distribute. To that, 2 times 3 is 6. 2 times negative x is negative 2x, less than or equal to 8. So now let's do step 1 of getting everything on the same side. X is already on the same side, we just need 6 over here. Those cancel, negative 2x, less than or equal to 2. Now step 2, sorry, is going to be to divide. So if we divide both by negative, the sign has to flip-flop because it's negative like this. It's now like